Hi there, it's Miss Uy again. In today's video, we'll be looking at the graphing of sine and cosine functions. All right, so we're going to look at graph that of the form of y equal to a sine n bracket t plus minus epsilon and y equal to a cos n bracket t plus minus the epsilon. So this is the graph that not just involve dilations, reflections, as well as horizontal translations. We will not be looking at vertical translation in this video. We will just focus on that 3 points that we mentioned before: dilations, reflections, and horizontal translations. So if you have the graph y equal to a sine n bracket t plus epsilon, so basically a tells you that there's dilation factor a from the x-axis, dilation factor 1 and n from the y-axis, and there is a translation of epsilon unit in the negative directions of the t-axis. Sorry, I should be saying t rather than x because the variable now is t. All right, so the second one is y equal to a. Again, a tells me that is a dilation factor a from the x-axis. Sine n, this n is dilation factor 1 and n from the y-axis, bracket t minus the epsilon. So there's a translation of epsilon units in the positive directions of the t-axis. So let's look firstly the reflections. As we know from our function level understanding of reflections, y equal to negative fx. The negative in front of the function is basically a reflection of y equal to fx in the x-axis. And the second one, y equal to f of negative x. The negative here is basically a reflection of y equal to fx in the y-axis. So here are two examples. Example y equal to negative 3 cos 2x. The negatives tells us that there is a reflection of y equal to 3 cos 2x in the x-axis. And the second one, the negative here inside the sine functions basically tell us there is a reflection of y equal to 5 sine 4x in the y-axis. Now today we want to further understanding of the odd functions and even functions. We know that sine graph is actually an odd functions, and because sine graph is an odd functions, so what does odd functions mean? Odd functions means that f of negative x is the same as negative of fx. So basically reflections in the y-axis is the same as reflection in the x-axis. So let's look at this graph that I sketched using CAS. The blue one is the original functions, and the green one basically has been reflected. So we notice here, if you look at the green, it tells me there is a reflections in the x-axis. I actually sketched reflection in the y-axis, but it doesn't show here. Basically, the sine negative x and negative sine x is actually the same graph. Okay. So how about for cosine function? Cosine functions is an even function, and we know that for even functions, f of negative x is the same graph as f of x. So reflection in the y-axis is the same curve as the original. Let's have a look here. So let's just draw cosine curve and draw the other side. Okay, can we see here reflection in the y-axis? Okay, reflection in the y-axis, you get back the same graph because they are the even functions. Okay. Right, next part. We're going to look at use CAS to sketch that. So I use CAS to sketch that. And we could see here the graph has been shifted pi and 4 to the left. Not only been shifted, of course, there is a dilation factor 3 from the x-axis as well. So you can see amplitude change. Period doesn't change, but the shift, all right, has been shifted or has been translated pi and 4 in the negative directions of the x-axis. So here in this example, we want to sketch a graph of y equal to negative 5 cos negative 2x for x between 0 to 2 pi. Let's look at the first one first. Okay, firstly, let's write down the important information. The amplitude is 5. The period is 2 pi on 2, which is pi. And the scale that we're interested in quarter of the period, which is pi on 4, and that's how we got pi on 4, 2 pi on 4, 3 pi on 4, and pi. So you start with pi on 4 and keep adding pi on 4 to that, 5 pi on 4, and you keep going on, all right, until 2 pi. All right, I actually start this graph with just a basic, without any reflections. So I start drawing y equal to 5 cos 2x. But of course, we're not going to do that in future, just to show you what happened, what's the difference between 5 cos 2x and 5 cos negative 2x. And we sketch that reflections in the y-axis. It doesn't change the graph. It's the same graph. Can you see that 5 cos 2x is the same as 5 cos negative 2x? But reflection in the x-axis, so our basic cosine curve from 0 to 2 pi. That's a basic cosine curve, okay? But when it's a reflections in the x-axis, what will happen is the max will become mean, the mean will become max. So that's the other graph. That's reflections in the x-axis. So we're going to reflect that graph in the x-axis. That's 5. That's negative 5, by the way. Max become mean, mean become max. X-intercept doesn't change. Okay, so let's sketch this with smooth curve. Ooh, my graph shifted a little bit. It's all right. Okay, so that's negative 5. All right, so negative 5 cos 2x, of course, is the same as negative 5 cos negative 2x. So let's look at the next one, which is a sine curve we're looking at. So what's a basic sine curve looks like? That's a basic sine curve. Okay, quadrantal point. But there is a reflections in the y-axis. Remember, sine is an odd functions. Reflection in the y is the same as reflection in the x. So we could actually write like this first. So what we do is we're interested in graph that's reflected. And the graph looks like this. Okay, let's write down the amplitude for this, which is 3. What's the period? 2 pi divided by 3. Yes, dilation factor 1/3 from the y-axis. And the scale is always a quarter of the period, which is 2 pi and 12, which is pi and 6. So let's put that scale down. Pi and 6, 2 pi and 6, 3 pi and 6, 4 pi and 6, 5 pi and 6, 6 pi and 6, 7 pi and 6, 8 pi and 6, of course 4 pi and 3, 9 pi and 6. We can simplify that if you want to. 10 pi and 6, which is pi and 3, 11 pi and 6. Okay, next is 3. Okay, the range is minus 5. Hang on, it's minus 5, not minus 5. 5 is the other one. So it's minus 3 to 3. Okay, put down this and that. So let's start with our quadrantal point. Center. There's a reflection, so go to the minimum. So every quarter of the period, something happened. Changes from, so that's the center, go to the minimum, back to the center, max, and hopefully I can get a nice curve from here. Ooh, Try to not draw a double line graph. Change a smooth curve. It's hard to draw on a stylus. Expect a nicer graph from you. Okay, I think that's to my best ability. I get a nice curve here. It's 2 pi 0, 0, 0. So label all your endpoints. How many cycles inside here? Do you know? You take 2 pi minus 0, which is 2 pi. So the number of cycles, which is 2 pi divided by the period 2 pi on 3. So it's 3 cycles. Is it 3 cycles? Yes, it is 1, 2, and 3 cycles. All right. That's all for this one. And let's look at the next question. Okay, let's look at the steps on how to sketch graphs that involve horizontal translations. And step 1, you need to transpose rule in the standard function form. So this is the standard function form a sine n t plus the epsilon. So you take out the n. Or could be t minus epsilon depending on the questions. For cosine curve, we're looking at a cos. Take out the factor n, t either plus or minus the epsilon. That's the standard function form. Then the second part, step 2, you identify the periods, the amplitude, and the horizontal translation factor, the epsilon. Whether it's translation epsilon unit to the right or epsilon unit to the left. The third one is you determine the scale, which is just period divided by 4. Everything significant, max, min, x-intercept happen every quarter of a period. And then you add multiples of the scale to the epsilon. Okay, and mark this along your x-axis over the required domain. Number 5 is remember the shapes, the basic shape of sine x and cos x for x 0 to 2 pi inclusive of the endpoints, and apply to new scale and required domain and begin sketching this shape from x equal to epsilon. And number 6 is you determine the value of the endpoints, if not a key point. All right, the endpoints, the x-intercept, the y-intercept, of course. Okay. All right, example 18, we're going to sketch y equal to 3 sine 2x plus pi 3 for the given domain. So step 1, we're going to transpose the rule in the standard function form. So y equal to 3 sine, take out these 2, so bracket x plus, if I take out 2, I need to divide pi 3 by 2, so that's how I got pi 6. So let's check 2 times x, 2x, 2 times pi 6 is pi 3. That's correct. So step 1, transpose rule in the standard function form. Step 2, identify the period, which is 2 pi divided by 2, which is pi. The amplitude is 3, and the h, which is the horizontal shift, is a shift of pi on 6 to the left. Okay, so negative pi 6, or you can equate this whole lot equal to 0, and you solve for x. You can see here x is negative. So h is negative pi on 6, and determine the scale, which is step 3. Take the period divided by 4. So the period is pi divided by 4. So it's pi on 4. And next, we're going to look at step number 4. All right, in step 4, we're going to add multiple scale to the epsilon, and we're going to map this along your x-axis over the required domain. So the scale here is the period, which is pi divided by 4, pi and 4. The h, which is a horizontal shift, it is negative pi and 6, so it's pi and 6 to the left, basically. Now, we want to make that as a common denominator because we are adding negative pi and 4 to negative pi and 6. So for easy additions, we make it common denominator. So 6 and 4, the lowest common denominator will be 12. So pi and 4 become 3 pi and 12. Negative pi and 6 become negative 2 pi and 12. So begin by marking negative 2 pi and 12 on your x-axis, and then you're going to add successively bigger multiple of the scale, or you can just keep adding 3 pi and 12. So if I add 3 pi and 12 to negative 2 pi and 12, I'm going to get pi and 12. If I add 3 pi and 12 to pi and 12, that will give you 4 pi and 12, and keep going, 7 pi and 12, 10 pi and 12, 13 pi and 12, 16 pi and 12, 19 pi and 12, 22 pi and 12, and 25 pi and 12, but 25 pi and 12 is outside the domain. We will stop at 2 pi. And recall the basic shape of y equal to sine x or y equal to cos x, depending on what we're looking at. So in our case, this is what we're interested. We're interested in sine x curve, and that's our basic shapes. And then the next step is we're going to find the endpoints. Our endpoints is 0 and 2 pi. Because our domain is from x greater or equal to 0, less than or equal to 2 pi. So you sub x equal to 0 into your functions, which is 3 sine 2x plus pi over 3. So when x equal to 0, you got 3 sine pi over 3. Okay, sine pi and 3 is root 3 on 2 times 3, so it's 3 root 3 on 2. Now, x equal to 2 pi, again you sub 2 pi into here, which gives you 4 pi plus pi and 3. 4 pi plus pi and 3 is the same back to the first quadrant, so which is sine pi and 3 times 3, same answer as before, 3 root 3 on 2, which is expected. Do you know why? Because there's a complete of 2 cycle within the domain. Every period is pi in this case, and so within that 2 pi, so we have 2 cycles. So when you start complete cycle, the y value where you start is going to end with the same y value. Okay. Then we're going to graph that in our next slide. Okay, let's sketch the graph. So let's begin labeling the x-axis and the y-axis. So remember the range, negative 3 to 3, square bracket. I draw the two faint line y equal to 3 and y equal to negative 3 to tell me the boundary. And the x-axis already labeled nicely according to the scale that we planned earlier. Negative 2 pi and 12, and pi and 12, 4 pi and 12, 7 pi and 12, 10 pi and 12, 13 pi and 12, 16 pi and 12, 19 pi and 12, 22 pi and 12, and of course, if I keep going, there'll be 25 and 12. But we're going to end at 2 pi. And we also know that from the last slide, we've already worked out what is f of 0, which is 3 root 3 on 2, which is the same as f of 2 pi. Okay? So we're going to put all these significant points down. 0, 3 root 3 over 2, and 2 pi, 3 root 3 over 2 here. Okay, and we already know our basic sine curve, sine x. Start from center, go to the max, center, minimum, and center. Right, same thing. But here the graph no longer starts 0, 0. It has shifted 2 pi and 12 to the left. So that will be the first point. And then go on to the maximum. Go to the center, minimum, center. That's one cycle. So keep going. Max, x-intercept, minimum, x-intercept. And if we keep going to 12, 25 pi and 12, that should be a max. So let's sketch this. Let's join that with a smooth curve. And don't forget, we should erase this part here. because it starts from 0. Okay. And it ends at 2 pi. Okay, let's check whether we need to, let's label all the endpoint and the maximum, minimum. Okay, so we have 2 complete cycles within here. That's the first cycle. Good. Okay, and then the second cycle. The 2 complete cycles inside here. I think that's all for these questions. All right, let's look at the last question. Pause the video, have a go, and then come back when you're ready. Okay, let's look at the last questions. So firstly, I want to rearrange these to standard function form. So I'm going to write this as 2 cos. The dilation factor is 2 from the y-axis, so take half out. X minus, careful, if I take half out, that will no longer be 2 pi and 3, but instead there'll be 4 pi on 3. So we can see here there is a translation of 4 pi on 3 to the right. Okay, now it is important for you to transpose that into standard function form, otherwise you may make that mistake and saying that there is a horizontal translation of 2 pi on 3 to the right instead of the correct answer, which is 4 pi on 3. So be careful with that. So amplitude, that's 2. The period is 2 pi divided by half, which is 4 pi. So the period is 4 pi, or you can look at it as there is a dilation factor of 2 from the y-axis. So remember, dilation factor from the y-axis changed the period. The period originally was 2 pi, and then you times 2, that's how we got 4 pi. The scale will be just the period, which is 4 pi divided by 4. Do you know why I divide by 4? Because quarter of the period. So the scale is pi. Okay, so we're going to put on our x-axis. Let's label that. Let's start with the h, which is 4 pi and 3. And then we're going to add pi to 4 pi and 3. Pi, instead of pi, I'll write 3 pi on 3. So we start at 4 pi and 3. It goes to 7 pi and 3. It's go to 10 pi and 3. You're adding 3 pi and 3. And then, of course, we're going to stop at 4 pi. Okay, we're going to find the endpoint when x equal to 4 pi. What's my y value? We're going to do that next. And now we go to the left of 4 pi and 3. So we're going to take away pi from 4 pi and 3, which give you pi and 3. Take away pi again, negative 2 pi and 3, negative 5 pi and 3, and of course, lastly, negative 8 pi and 3. But again, we are going to stop at negative 2 pi. So let's now look for the end values, the end point. What is the y value when x equal to negative 2 pi? So let's sub that into our functions. So 2 cos negative 2 pi divided by 2, that's negative pi, minus 2 pi and 3. So negative pi, negative 2 pi and 3. Let's locate where about in the unit circle. Is in the first quadrant, and that should be pi and 3. We're looking for the x value, which is a positive x value. It is cosine of pi over 3, which is half, times 2, which is 1. So when x is equal to negative 2 pi, y is equal to 1. So let's label 1, 2, -1, -2. So our range is actually from -2 to 2. I'm going to put a line here, very faint lines. Okay, to remind myself that will be my boundaries line. Now I am going to find when x equals 0. Oh, sorry, let's look at the 4 pi first. We have not done this bit. So let's sub 4 pi into here. 4 pi divided by 2. 2 pi minus 2 pi and 3. Again, let's draw the unit circle. It's 2 pi. And negative means going on the clockwise. So we are looking at the third quadrant. That's cos, that's pi and 3. So we're looking at -2 cos pi and 3. Third quadrant cosine is negative. So it's -2 times half, which is -1. So when x equal to 4 pi, the y coordinate is -1. When x equal to -2 pi, the y coordinate is 1. Okay, and let's look at the y-intercept when x equal to 0. So sub that in. So we're going to have 2 cos of -2 pi and 3. Where is -2 pi and 3? Which is what we already know in the third quadrant, which is -2 of cos pi and 3, which again going to give you -1. So that's my y-intercept. And let's look at our cosine graph, basic cosine graph. Quadrantal angle, the 5 points. Okay, now the graph actually has shifted 4 pi on 3 to the right. So our first point is not 0, 2, but 4 pi on 3, 2. Okay, and then it will go to the x-intercept, which is the center, first quarter, and then go to 10 pi and 3 at the minimum, and then it should go at 13 pi and 3 at the center, but we're going to stop at 4 pi. So that's where we're going to end. And then going to the left of 4 pi and 3, let's move left. So from max to center to the minimum, back to the center, which is my x-intercept. And of course, if we go to -8 pi and 3, there'll be maximum, but we're going to end at -2 pi. Now we are ready to sketch the graph. Join with a smooth curve. No double line, no hairy line. Okay, and we label all the points. That's -2. Let's make another minimum. -2. All right. So how many cycle in here? 1.5. Do you know how you work out? 4 pi, take away -2 pi, so 6 pi. Within the 6 pi, you divide by 4 pi. So there's a 1.5 cycle. And let's make sense. Look at here. Here to here, it's 1 cycle. Up to 1. And of course, the other one is a half of a cycle. All right. I think that's all for now. Go to your class OneNote and complete your exit tickets 12 and exit ticket 13. Bye for now.